Bohr's atomic model, na? Okay.
Yes, sir.
What are the limitations of the Bohr's atomic model, Jibian? We discussed some Bohr's atomic model. What are the limitations of the Bohr's atomic model?
So like it did not give the structure of the atom.
Yes. We didn't explain the structure of the atoms, which contains more than one electron.
An
Right?
electron.
More than one electron. Okay. Next, what is another limitation? What is another limitation? What is another limitation means? So it didn't explain the Zeeman effect and Stark effect. Okay, it didn't explain Zeeman effect and Stark effect. So what is meant by the Zeeman effect means here splitting of spectral lines in presence of magnetic field is called as a Zeeman effect. What is meant by the Stark effect means splitting of spectral lines in presence of electrical field is called as a Stark effect. Okay, and he violates the Heisenberg uncertainty principle and de Broglie wave equation also. Okay, so based on this one, in what are the JE level concepts we are having means? So we have a calculations based on the Bohr's atomic model. So which type of calculations we are having means? So based on the energy, we are having some of the calculations. What is the formula we are using to calculate the energy means? So because of when the electron is jumps from one energy level to another energy level means here, okay, either it loses the energy or it gains the energy. The losing of energy, gaining of energy can be represented, okay, or how we are going to calculate means delta E is equal to E2 minus E1. That is the formula we used. Is it right? Right now. Okay. Now, so based on this one again, so how we can calculate the energy? Nth energy. Okay. Nth energy of atom. Nth energy of atom. Sir, how we can calculate the nth energy of the atom? What are the formulas we are using means here? We have a different formulas now. Okay, so we have a different formulas. So what are the formulas we are having to calculate the nth energy means here? Generally, how they derive nth energy formula means here minus 2 pi square m z square e to the power of 4 divided by n square and h square. Okay, so this one is 2 minus 2 pi square m z square e to the power of 4 by n square and h square. If you simplify the values, if you substitute all the values, charge, mass, okay, and h is nothing but Planck constant value. In this one, what is the h mass? H is nothing but here Planck constant value. Okay, so mass of the electron and charge of the electron. If you substitute all together means, so what are the formulas we are getting means here? Based on units, we have a different formulas. Okay, sir, what are the formulas we're having means E is equal to minus 2.179 into 10 power minus 11 ergs per atom. Ergs per atom divided by Z square and N square. Z square and N square. This is the one formula. And what is another formula we are having in the calculation means here? Okay, minus 2.179 into 10 power minus 18 into Z square divided by N square. Z square divided by N square joule per atom. Joule per atom. And what is another formula we are having means here? Minus 1312 Z square by N square kilojoules per mole. Kilojoules per mole. Okay. And electron volts also. What is another formula we are having to calculate the energy means here? E is equal to minus 13.6 Z square by N square. This is electron volts per atom. So based on the units, we have a different formulas. Now we got the clarity. Okay. So in the calculation part, compulsory we have to remember all these formulas now. Okay, if they had given kilojoules means what is the formula we can use here? Minus the 1312 z square by n square. Okay, and what is the formula we can use to calculate the electron volts per atom means minus 13.6 z square by n square formula we are using. Okay, in this one, what is meant by the z? Z is nothing but, what is meant by the z? Z is nothing but atomic number. That is nothing but here atomic number. And what is meant by the n? N is nothing but here energy level. N is nothing but here energy level. Okay, so by substituting all these values, we can calculate the nth energy. Okay, energy of nth orbit we can calculate. Okay, so based on that one, what is another important one we are having means here? Next, we have a radius, nth radius. Okay, and radius. So what is the formula we are using to calculate the radius of an orbit? Okay, radius of nth orbit. What is the formula we are using to calculate the radius of the nth orbit? Radius of nth orbit. Radius of nth orbit. So Rn we can write. So what is the formula we can write means here? Rn is equal to 0.529 n squared by z. Okay, n squared by z. So by using this formula, we can calculate the radius. Okay, and radius also we are going to represent in Armstrong units. We are going to represent the radius, my dear. Radius can be represented in Armstrong units. Clear? And one more formula also it is there. So what is another formula we are having means here? Velocity. Okay, we have another formula to calculate the velocity. So what is the formula we are using to calculate the velocity means here? Velocity is equal to 2.188 into 10 power 8 divided by n centimeter per second. N centimeter per second. Okay, in this one, 2.188 into 10 power 8 divided by n centimeter per second. So by using this formula also we can calculate velocity. Okay, so by using this formula we can calculate the velocity of nth orbit. So these formulas are very, very important to calculate the energy and radius and velocity. Clear? Okay, so compulsory we have to learn these formulas one. So based on that one, we are having some of the calculations. Okay, so to make you understand, just I'll give some questions. Okay, some simple calculations only I'm going to be give you. Okay, right now. Here they had given one question, ma. So calculate the radius of the Bohr's third orbit in Li2 plus ion. Okay, they had given one question here. So what is the question they had given means here? Calculate the radius of the Bohr's orbit. Radius of Bohr's orbit. Radius of Bohr's third orbit. Third orbit in Li plus 2. In lithium plus 2 ion. In lithium plus 2 ion. So any one of you, how we can calculate here? What is the formula we are using to calculate the radius? Rn is equal to 0.529 into n square by z is the formula. Na? In this one, what is the n value? Any one of you? What is the n value? Samhita J. What is the n value as per the question?
Sir, 3.
Very good, Sriyuta. N is equal to 3. N is equal to 3. Then what about the Z value?
3, sir.
Atomic number of the lithium, 3. Okay. Now if you substitute the values, that means 0.529 into, so 3 square means directly I'm writing as a 9 divided by 3. That means 3 ones, 3 threes, and 3 into 0.529. If you simplify that one, means how much value you will get, ma? How much value will you get? 0.529 into 3. So 3 nines, 27. So 3 twos, 6. 6 plus 2, 8. Okay. And 3 fives, 15. Right, ma? 15 means here 1.587 Armstrong unit. Hence, what is the radius, ma, here? The radius of third Bohr orbit of the lithium is 1.587 Armstrong units. Got the clarity? Still anyone you having doubt?
No, sir.
Okay, next, one more question. So one more simple question I am going to give here to calculate the energy. Okay, to calculate the energy. Here they're asking energy and radius, both they're asking. Let us see, ma. So what is the question they're asking means here? Calculate the energy associated with the first orbit of helium. Calculate the energy associated with first orbit of helium plus 2. Question is, my question is, calculate the energy associated with the first orbit of He plus. So how we can calculate, ma? Answer is they had given as a joules. Answer is they had given as a joules. What is the formula we can use? We have a different formulas now. In that one, which formula we can use to calculate the energy? Samhita, J, Sri, Yuta. Which formula we can use to calculate?
Minus 2.179 into 10 to the power minus 9.
2.179, that is only we can write as a 2.18 also. Okay, into
10 to the power minus 18 by n square into z square.
N square into z square by n square. Z square by n square is the formula. Okay, so what is the Z for the helium?
2.
What is the atomic number of the helium? Atomic number of the helium is equal to 2 square. Okay, calculate the energy associated with first orbit. First orbit means here 1 square only, na? Okay, first orbit is nothing but here it is 1 square. Now if you simplify that one, means how much you will get the answer here? 2 2s are 4. Okay, so 4 nines, 36. 4 sevens, 28 plus 3, how much, ma? 31 again. Okay, 4 ones 4, 4 plus 3, 7. Okay, so 3 twos, 6 point. So minus 6.716 into 10 power minus 18 joules is the answer. Okay, anything wrong, ma? 4 twos are 8, na? Sorry. 4 twos are 8. Okay, 8.716 into 10 power minus 18 joules is the answer. Clear? So this kind of formula based questions are there in your examination part, but they won't ask this much of easy in the examination part. They are going to be interlinked to the another atom also. The comparison type of the question they are asking. Okay, they are asking here comparison type of the question, so that you are able to solve. Already I forwarded some of the previous year questions. Okay, have you seen the PDF file or not? All of you, have you seen the PDF file or not? Everyone?
Yes, sir.
Okay, so just you go through that one. You have some questions in that one here. Clear? Okay, then we'll go for the next concept here. Okay, so what are the next concept means here? Based on some basic concepts also, they're asking the questions in the JEE level. Sir, what is the basic levels means here? First, the isotopes, isobars, isotones, isoelectronic species, isosters and all. So what is meant by the isotopes? What is mean by the isotopes? And is any example? Isotopes. Samhita, what is meant by the isotopes? Isotopes are nothing but the atoms of the same element having same atomic number but differ in their mass. So what is the difference here? Mass number. Okay, what is meant by the isotopes means here the atoms of the same element having same atomic number but differ in their atomic mass is called as a isotope. Sir, what are the examples means here? Hydrogen. Hydrogen can be exist into 3 isotopes. What are the 3 isotopes here? H11, that is only we can call as a protium, deuterium and tritium. Okay, so protium, deuterium, tritium, and carbon also it is going to be exhibit as the 3 isotopes now. So one is C6, H12, C6, H13, and C6, H14. Okay, C12, C13, and C14. So all these are the examples of here isotopes. In this one, if you observe, means atoms of the same element having similar at the same atomic number but differ in their mass number is called as a isotopes. And what is meant by the isobars? What is meant by the isobars? What is meant by the isobars? Isobars are having same atomic mass, differ in their atomic number is called as a isobars. Okay, the atoms of the different elements are having similar atomic mass but same atomic mass but differ in their atomic numbers is called as a isobar. Sir, what are the examples for that means here? Carbon C16, C6 and C14. Nitrogen also it is exhibit as a C7 and 14. Okay, nitrogen exhibit as here 7 and 14. These two are we can consider as a isobars. Sir, how you are telling that these two are we can consider as isobars means here? So these two are having same atomic mass but differ in their atomic number. And one more also we can write. So what is another one means here? For example, argon. Argon atomic mass is 39, 40. Argon atomic mass is 40. What is the atomic number of the argon? 18. Potassium atomic mass is 40. Atomic number of the potassium is 19. And calcium atomic mass is 40. Atomic number is equal to 20. So all these are we can consider it as a isobars. Isobars are nothing but the atomic mass is same but differ in their atomic number is called as a isobars. Okay, and what is another example? Next one here, isotones. Okay, isotones. So what is meant by the isotones? What is meant by the isotones? The atoms of different elements. Atoms of different elements. Atoms of different elements having different atomic number, different mass number, but same number of neutrons, but same number of neutrons, is called isotones. Isotones are having different physical properties and different chemical properties. Okay, so what are the examples of the isotones means here? Once you check it out here, I'm writing as a two example. One example is carbon C6, 14 and oxygen 8 and 16. Okay, 8 and 16. How we can calculate the number of neutrons? Anyone? Number of neutrons is equal to A minus Z. In this one, A is nothing but atomic mass and Z is nothing but atomic number. Okay. Now the number of neutrons present in C14 isotope. How many neutrons are there?
8.
8 ma. Very good ma. Okay. It has 8 neutrons. And in O16, the number of
8.
neutrons is equal to O16 here, 8. So that means both are having different atomic number and different mass number. But which one it is the same? It is there. Both are having same number of neutrons. If they're having same number of neutrons, means that we can call it as a isotones. Got the clarity? Okay. Next. So what is the isoelectronic species? Isoelectronic species. Isoelectronic species. What is the isoelectronic species? Isoelectronic species. So what is the isoelectronic species? So what is the isoelectronic species means here? The atoms or ions which are having same number of electrons. Same number of electrons is called as a isoelectronic species. So which we can call as isoelectronic species means here the atoms or ions which are having same number of electrons is called as a isoelectronic species. Okay, for example, here what is the example means here? First, sodium Na plus and Mg plus 2. Mg plus 2, Al plus 3 and neon. The number of electrons present at neon is equal to, how many electrons are there in neon?
10 electrons.
Sodium?
11.
11. Na plus ion ma?
Oh, 10.
10. Mg plus 2?
10.
Al plus 3?
10.
Okay. Number of protons. All these are, you told that electrons. Let's check it out the number of protons. How many protons are there with the neon?
10.
10. Number of protons present at sodium?
11.
11. Here 12. Here 13. So because of number of protons is equal to atomic number. Okay, so number of protons can be represented with the atomic number. So if you see means neons, Na plus, Mg plus 2, Al plus 3, all are having same number of electron. Whenever they're having the same number of electrons means that we can call as a isoelectronic species. Okay, and isosters are there. Isosters, previous year question here. So what is mean by the isosters means here? Different molecules are having same number of atoms, and same number of electrons. Same number of electron. Okay. Simply different molecules are having same number of atoms and same number of electrons means that we can call as a isosters. So what are the example means here? For example, they had given as here carbon dioxide, CO2 and NO2. First of all, you can check it out the number of atoms. In CO2, how many atoms are there? The number of atoms present in CO2?
3.
3. Very good, ma'am. The number of atoms present in N2O. It's not the NO2. It is N2O. N2O. Number of atoms present in N2O?
3.
3. The total number of electrons in carbon dioxide? Samhita, the total number of electrons present in carbon dioxide? The total number of electrons present in carbon dioxide. Carbon atomic number. Carbon atomic number is equal to 6. Oxygen atomic number is equal to 8. How many oxygens are there? 2 are there. So that means 6 plus 16. 6 plus 16 means total number of electrons is equal to 22. Carbon dioxide is containing 22 electrons. Okay. And N2O, the number of electrons present in each nitrogen atom is 7. 7 into 2, 14, plus number of electrons present in oxygen, 8. Okay. 7 twos, 14 plus 8. 14 plus 8 means how much, ma? 22 only, na? So N2O also they contain 22 electrons, and carbon dioxide also it contains here 22 electrons. Got it, all of you?
Yes, sir.
Okay, same number of atoms and same number of electrons with that we can call it as a isoelectronic species. Clear? The next we'll discuss about the nature of the light. Okay, nature of light. I think so this concept you may studied in 10th standard also. Nature of light. Okay, so actually the nature of light can be explained based on wave theory. Wave theory. And what is another theory means here? Second one is corpuscular theory. So what is another theory mean here? So corpuscular theory. Two theories are there. Okay. So one is wave theory, corpuscular theory. Okay. Now, so first one we can check it out. So wave theory. So what is meant by the wave theory? So who proposed the wave theory means here? Huygens. So who proposed the wave theory, ma? Huygens. Okay. So what he's telling that means here, whatever the light it is that it travels in the form of wave. It travels in the form of wave. 1 second, ma. I want to draw some diagram. You got the diagram, ma? So this is the wave theory. Let us see. So in this one, what happened? How the electrons is how the light is going to be travel? So light is travel in the form of wave or not? Sriyuta?
Yes, sir, it is.
Okay. So in this one, when the light is travels in the form of wave, okay. So light particles are there. Light particles are they can move with high velocity. Okay. So whenever they can move in high velocity, they can generate the electrical field and magnetic field. Okay. Are you going to observe the electrical field and magnetic field, ma? Okay, so which one is considered as an electrical field means the pink color line is it represent as a electrical field. Okay, and blue color line is it represent as a magnetic field. Electrical field and magnetic field are so one is perpendicular to another one. Okay, right, ma? Okay, so here light is it travels in the form of wave. Whenever it travels in the form of wave, it generates the electrical field and magnetic field. Electrical field and magnetic field are one is perpendicular to another one. In the absence of electrical field and magnetic field, light is travels in a straight line. Okay, in the absence of electrical field and magnetic field, light is travels in the form of here straight line. So based on that one, we are having some of the terms for here. So what are the terms we are having means here? First one is wavelength. First one is here wavelength. Sir, what is mean by the wavelength? How we are going to represent the wavelength? How we are going to represent the wavelength? What is meant by the wavelength? Wavelength can be represented with lambda. How we are going to represent the wavelength here? Wavelength can be represented with lambda. Sir, what is meant by the wavelength means here? Sir, whatever the above curves are there, that we can call as a crest. That we can call as a crest. And below one, whatever it is there, that we can call as a trough. That we can call as here trough. Okay, the distance between two crests or the distance between two troughs is called as a wavelength. Okay, so what is meant by the wavelength means here the distance between two crests or the distance between two troughs is called as a wavelength. So what are the units of the wavelength means? Wavelength can be represented with Armstrong units or nanometers or picometer. So one Armstrong unit is equal to how much, ma? One Armstrong unit is equal to in meters. We can write as a 10 power minus 10 meters only now. If we take in centimeters means how we can write 10 power minus 8 centimeters. And one nanometer is equal to 10 power minus 9 meters. And 10 power minus 9 minus 7 centimeters. Okay, one picometer is equal to 10 power minus 12 meters. 10 power minus 10 centimeters. So now we got the clarity. So these are the units of the wavelength. Okay, and so frequency it is there. Frequency. So how we can define as a frequency? Frequency can be represented with nu. Frequency can be represented with nu. Okay, so how we can represent as a frequency? How we can define as a frequency means here the number of waves crossed at one particular point in 1 second is called as a frequency. Okay, let's consider it is as a one particular point here. Okay, here it has a one particular point. At this one we can consider as one particular point here. So at this particular point, the number of waves crossed at this particular point in 1 second is called as here frequency. Okay, so frequency is we can write as a nu. So nu is nothing but c by lambda. How we can write means here nu is equal to c by lambda. So in this one, what is meant by the c means here? C is nothing but velocity of light. C is nothing but here velocity of light. Okay, so now you got the clarity. And lambda is nothing but wavelength. Then wave number. Then wave number. So what is meant by the wave number here? Wave number can be represented with nu bar. Okay, wave number can be represented with here nu bar. So what is meant by the wave number means here the number of waves present in a unit length. Okay, the number of waves present in a unit length area is called as a wave number. Simply, how we can define as a wave number means here, wave number can be defined as it is the reciprocal of wavelength, also we can call as a wave number. Okay, it is the reciprocal of wavelength, also we can call as a wave number. Okay, and amplitude. So what is meant with the amplitude? Amplitude is nothing but the height of the crest or depth of the trough is called as an amplitude. So what is meant the amplitude means here? Amplitude is nothing but height of the crest or depth of the crest trough is called as a amplitude. And what is meant with the velocity? What is with the velocity? What is meant by the velocity? What is meant by the velocity? So velocity is nothing but the distance traveled by the light in 1 second is called as a velocity. So what is meant by the velocity, ma? So velocity is nothing but the distance traveled by the light in a 1 second is called as a velocity. Okay, then next. So what is the next? It is that means here electromagnetic spectrum. Okay, next we have here electromagnetic spectrum. Electromagnetic spectrum is explained by here corpuscular theory. Okay, in electromagnetic spectrum, whatever the radiations are there, okay, whatever the radiations are there, either it is emitted or absorbed in the small of discrete particles. Okay, they cannot be traveled by here, so they cannot be continuous manner. They will be in a discontinuous manner. Okay, so that it is explained by the corpuscular theory. Okay, and corpuscular theory also we are going to study about the black body radiation. So what is the black body radiation? Any one of you? What is the black body radiation? What we can call as a black body? First of all, what is the black body? Black body, ma. Samhita, what is the black body? Black body is nothing but black color dress. Is it right?
Sir, a black body can emit and absorb radiation simultaneously.
Simultaneous, sir. It's not the
Or
correct statement. No,
and
ma.
like it can do both, from what I know.
Okay, so actually what is the black body means here? The substance which absorbs, emits all frequencies of the radiation is called as a black body. Sir, what is the best example for the black body means black color dress? Okay, are you able to wear the black color dress in summer season, ma?
No, sir.
So why we are not wearing as a black color dress in summer season? What is the reason?
Because it attracts a lot of sunlight.
Very good. It absorbs the sunlight. Whenever it absorbs the more sunlight means we will feel very hot. Okay. At the same time, so generally black color dress we used to wear in winter season. We like to wear in winter season. What is the reason?
Because during winter season it absorbs sunlight and like that makes us feel warm during the
Very
winter season.
Very good, Javier. Yeah, very good answer. Okay, actually, winter season we can feel as a little bit cold. Okay, so whenever you're feeling as a little bit cold or something means if you are wearing black color dress means it absorbs the low radiation of the sunlight also. Whenever it absorbs the low radiation of the sunlight also, it generates the heat and it make it as a warm. At the same time, from body also, it absorbs the heat energy. That means it absorbs the heat energy, it generates the internal heat energy. That time we feel little bit warm. So due to that reason only, so black color dress. So black color dress is nothing but best example of the black body. So what is the black body means here? The substance which absorbs and emits all frequencies of radiation is called as a black body. Okay, and the whatever the radiation is there, that we can call as a black body radiation. Sir, who proposed the black body radiation means here? Okay, Planck's quantum. Okay, so which one here? Planck's who discovered the black body means here? Maxwell Planck. Okay, Maxwell Planck, he discovered the black body. Okay, in that also, if the temperature is going to be increases, let us see here. So we have a one condition. If the temperature, it is the T1 temperature. Okay, if the temperature is going to be increases means if the intensity of the radiation is going to be increases by reaching the maximum value, again it becomes as a decreaser. So when it is going to be decreases means by increasing of the temperature. If the temperature is going to be increases means the intensity of the radiation is going to be increases by reaching the maximum value, then it is going to be decreases. Based on that one, what we can say, T2 is greater than that of the T1 only now. Okay, so based on that one, what we can say means here, we can say that is here T2 is greater than that of here T1. Okay, so based on this one here, so what is meant by the Planck's quantum theory? We have a Planck's quantum theory. Planck's quantum theory. So what is meant by the Planck's quantum theory? Any one of you? Now only you are telling that, sir, energy is going to be emitted or energy is going to be absorbed. Whatever the energy is emitted or absorbed in a discontinuous manner. It is not in a continuous manner. Okay, the emission of the radiation or absorption of the radiation, it will be in a discontinuous manner. So whenever it is in discontinuous manner means here, it divided into small energy packets. That small energy packets only we can call as a quantum. What is meant by the quantum means here a small energy packet. A small energy packets are called as a quantum. Okay, the energy of the quantum is directly proportional to the frequency. If the frequency is going to be increases, means energy also is going to be increases. To simplify the formula, how we can define here? To remove the directly proportional, we are taking as a constant. Then we are writing as a h nu. Already we know the nu. What is the nu? In place of nu, what we can write? Nu is equal to hc by lambda, we can write now. We can write or not? In this one, h is nothing but Planck constant value. What is the Planck constant value here? 6.625 into 10 power minus 27 ergs per second. Okay, or 6.625 into 10 power minus 34 joules. Okay, 6.625 into 10 power minus 34 joules second. So if you substitute all these values, means we can calculate the energy. Clear? Okay, same based on that one more also it is that Einstein equation. Einstein equation. Sir, what is meant by the Einstein equation means here? Einstein is explained the emission of the energy or absorption of energy in the small discrete particle. That small discrete particle is called as a photon. Okay, the energy of the photon is directly proportional to the frequency. Okay, the energy of the photon is directly proportional to the frequency. So based on that one, he wrote as here, E is equal to mc square. In this one, c is nothing but velocity and mass of the particle. Okay, and it is directly proportional to mc square. This is the formula is given by the Einstein. So these two equations, by using these two equations, we can derive the de Broglie wave equation also. That we will discuss tomorrow. Okay, until here, once you go through the concepts, based on that one, you're having some of the questions in your previous papers. Okay, just to solve that questions. If you're having any doubts, just to post in a group. Okay.
Okay,
Right,
sir.
Javier? All of you.
So,
Okay, once go through the question, but just for the sake of the idea. Okay, and
okay, so
so recently I got some previous year questions also, which are happened January scheduled JEE questions I got. That is also I'll post in the group. Chapter wise we got. Okay, I'll forward that one also in the group. Okay, you can practice that questions also. Okay, Samhita, Sriyuta.
Yes, sir.
Yes,
Right.
sir.
So we'll continue in the tomorrow. Okay. Thank you all.
Thank you, sir.
thank you, so.
Thank you, sir.
Welcome.